Now I'm going to show you some of my own notes that I did when I was in 10th grade, which is like about a year ago. So yeah, so trigonometric ratios of general angles. That's the topic. And now let's look at this. You don't, the notes are very detailed, but you don't really have to know so much in order to like get high marks for like this chapter. So these notes have like extra things that aren't really part of the syllabus, but it might be good for you to know. Okay, so I told you that this would be the first quadrant, this is the second quadrant, this is the third, and this is the fourth quadrant. And then this is the positive, this is the negative angle. So the angle that is made by the terminal ray, which is this, terminal means that it's gonna like move away. So yeah, from the origin, which is the initial ray. So this is the initial ray and this is the terminal ray. Can either be positive or negative. So if the terminal ray rotates in an anti-clockwise direction, it is positive. Whereas if the terminal ray rotates in a clockwise direction, it's negative. I also forgot to mention this point over here. So we know that x squared plus y squared in this case would be 1, right? Or 1 squared. So if we actually plug in these values, we'd get cos squared theta plus sine squared theta equals to 1. This is one of the trigonometric identities we're going to learn for in like the next chapter. So yeah, this is very important. So cos squared theta plus sine squared theta is 1. You need to remember that. Okay, moving on, let's come back to this topic. So 30 degrees would be negative 330 degrees and negative 30 would be 330, and this one 420 would be 60 because 420 by 360 is 60. So yeah, so 80 would also be negative 280. Okay, so this one is going to be a little complicated and out of the syllabus. So my teacher taught me this, but then you don't really have to know. You can, I mean, it's good to know, but like it won't be asked in the exam. So this part won't be asked in the exam. So x, the derivation will not be asked, I mean. So an x coordinate is the first element in an ordered pair. So like when you're writing coordinates, you write the x coordinate first and then the y. So it's the first element in the ordered pair. Okay, so x is also called abscissa, and then the x coordinate represents the directed distance of the something I didn't write from the y-axis, distance of something from the y-axis. And y coordinate is also called ordinate, and the y coordinate represents the directed distance of the something from the x-axis. So sine theta, okay, now let's draw the triangle here. So sine theta, this is the angle, by the way. So sine theta would be opposite by hypotenuse, which is y by r. And cos theta would be x by r, and so on. We'll learn these a little later. We'll just focus on the first three right now. So yeah, and tan theta would be y by x. Okay. And also I've made this point. Also, 2n pi plus or minus theta equals to plus or minus theta, where n is an integer because it is periodic, meaning it repeats. That's what I've told. And sine 1110 would also be sine 20. So we know that sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. and tan 90 minus theta is cot theta. So memorize this. So you have to memorize these. So yeah. And then I have written down the proof of it, but you don't really have to know that. And then similarly, so you don't really have to know like how to derive the thing, you just need to know it. Know like the formula. So sine 90 plus theta would be cos theta, and cos 90 plus theta would be negative sine theta. You might be confused why this is plus, this is negative. Let me show you this. So you'll have to remember this. All students trust Cambridge in order to find whether it's going to be positive or negative. So in the first quadrant, what this means is that starting from the topmost box, which is also on the right, you'll have to go in the anti-clockwise direction, assigning each quadrant the alphabet. So this would be A, so all students trust Cambridge. So A means all trigonometric functions. S would be sine, T would be tan, C would be cos. So this means that all of the ratios, all of the sine, tan, cosine will be positive in this quadrant. And in this, only sine is going to be positive, and cos and tan will be negative. In the third quadrant, tan is going to be positive, but sine and cosine are going to be negative. In the fourth and final quadrant, cos is going to be positive, and sine and tan are going to be negative. So, yeah. If you think about it, in the second quadrant, sine is going to be positive. So that's why this has a positive I don't know, coefficient. Yeah. So, and then cos 90 plus theta would be negative, because in the second quadrant, cos and tan are negative. So, yeah. And then so on. And then there's a lot. I will just show you this if you want to copy. This is the next. Here we're dealing with 180 degrees. I will tell you like a rule of thumb that you can follow instead of having to memorize all of these. But for now, you could just copy these down. So this is extremely important. This means that it's in the third quadrant. This means it's in the second quadrant. And these. This is in the fourth quadrant. That's why, no, it's in the third quadrant. That's why only tan is positive. And finally, this is the fourth quadrant. So cos will be positive, the rest will be negative. And then this would be 360 minus alpha. So it's 270 plus alpha. Okay. So now that you've seen this, I will tell you a rule of thumb that you can use. So if it is the even multiples of 90, for instance, plus or minus alpha, 180 plus or minus alpha, and 360 plus or minus alpha, it will be b itself. But if it is the odd multiple of 90, for instance 90 or 270 plus or minus theta, it will be the co-ratio of it. The co-ratio will basically be sine will be cos, tan will be cot, and cosine, No, cosecant will be secant. So yeah, you can use this. And then in the first quadrant, all are positive. Second, it's going to be sine positive. Third is going to be tan positive. Fourth is going to be cos positive. So you can either use this or this. So all students trust Cambridge or all students take coffee. Okay, so now I will just show you a few examples on how to solve this. Okay, so let me take a screenshot of this and paste it here. This is extremely important. Okay, so now okay, so if we want to simplify cos 270 plus 30, 270 is an odd multiple, right, of 90. So it will be the co-ratio, so which is sine. So it's going to be sine 30. And this is in the fourth quadrant, so it's going to be plus. So if you plug the value of cos 300 into your calculator, you'll get 1 by 2. And this will also be 1 by 2. So this is how you use this information. And then you can like try for like any values. So yeah. This could also be written as cos negative 60. And like you can try with various values, different trigonometric ratios, and you could try it. I'm hoping that this concept is clear. So let's move on to a few questions. So the first question states the following. Find all angles between 0 and 360 degrees with a sine of 1 by 2. So first, let's do sine inverse of 1 by 2. We get 30 degrees. So if sine theta equals to 1 by 2, then theta is sine inverse of 1 by 2, which is 30 degrees. And now if we want to find the other angle, let's first draw the table. So this is all students trust Cambridge. So we can see that sine is positive in the second quadrant. If we do 180 minus 30, because sine of 180 minus 30 is essentially sine 30, because 180 is a positive, not a positive, an even multiple of 90. So that's why this is going to remain the same, and it's going to be positive because it's in the second quadrant. Thereby we get sine 30. So therefore theta is also equal to 180 minus 30, which is 150 degrees. So our answers are 30 degrees and 150 degrees. Moving on. So this is the second question. It's somewhat similar. So first, let's write down the equation. So it's sine theta equal to root 3 by 2. So theta is sine inverse of root 3 by 2. When we do this, we get 60 degrees. The same rule applies here. All students trust Cambridge. So sine is positive in the second quadrant. Therefore, theta equals 180 minus 60, which is 120 degrees. Okay, now the third one. So a cosine of negative 1 by 2. So cos theta equals to minus 1 by 2. So theta would be cos inverse of negative 1 by 2. We get 120 degrees. Let's draw this again. In the first and the fourth quadrant, cos is positive. So therefore, we're supposed to look at the second and the third because negative 1 by 2 is negative. So we're supposed to find a value which is in the third quadrant. Therefore, theta is 360 minus 120. Now this would lie in the third quadrant because cos 360 minus 120 degrees would be cos 120. They would be the same because this is an even multiple of 90. So yeah, therefore theta is also equal to 240 degrees. These two are the answers. Now let's solve the final part of the first question. So cos negative 1 by root 2, no wait, my bad. Cos theta equals to negative 1 by root 2. So theta will be cos inverse of negative 1 by root 2. So if we find that, we get 135 degrees. And similarly, theta would be 360 minus 135, just 225, and it lies in the third quadrant. So therefore, our answers are 135 and 225. Now that we've finished this question, now let's look at the next question. So we have to find theta if theta lies between 0 and 2 pi, and it's given that cos theta is 1 by 2. Cos theta is 1 by 2, so theta will be cos inverse of 1 divided by 2, which is 60 degrees or pi by 3 radians. We have to write this in terms of radians because that the range that they have given us, the domain, it's in radians. So therefore, one of the answers is pi by 3. And now let's draw the quadrants. So that's all students trust Cambridge. Cos is positive in the first and the fourth quadrant. So the other value of theta is 2 pi minus pi by 3, which gives us 5 pi by 3 radians. So the two answers are pi by 3 and 5 pi by 3. Okay, now let's look at the next one. It's given that sine theta is root 3 by 2. Therefore, theta is sine inverse of root 3 by 2, which is also 60 degrees or pi by 3 radians. But the second angle won't be the same. We'll look at it. So this is the reason all students trust Cambridge. And then sine is positive in the second quadrant. Therefore, the next value of theta would be pi minus pi by 3, which is 2 pi by 3. Now let's solve the last one. So cos theta is minus 1. So theta be cos inverse of minus 1, which is pi. The second angle will also be the same because 2 pi minus pi is pi. So therefore we only have one answer, which is pi.